Hello everyone, and welcome back to the Navy News Network channel. Today, we're diving into a crucial aspect of naval operations, the decommissioning and recycling of submarines, especially nuclear-powered ones. As essential assets of naval warfare, submarines eventually reach the end of their operational lives, and their responsible decommissioning is a significant task. Submarines play a vital role in national defense and maritime strategy. However, like all military vessels, they have a finite lifespan. Once they reach the end of their service, they must be carefully decommissioned and recycled. This process is intricate and requires meticulous planning to ensure safety, environmental protection, and the recovery of valuable materials. Over the decades, the United States has developed a comprehensive strategy for disposing of and recycling decommissioned submarines. This strategy allows the nation to maximize the value derived from these vessels while adhering to stringent safety and environmental standards. The decommissioning process generally begins with the defueling of the submarine. This step is critical for nuclear submarines, as it involves removing the nuclear fuel from the reactor to ensure that the vessel is no longer capable of operating. The removal of nuclear fuel must be conducted by highly trained personnel in secure facilities, following protocols designed to protect both the workers and the environment. Once the submarine has been defueled, the next stage involves the decommissioning of the nuclear reactor, if applicable. This process includes dismantling the reactor and safely storing or disposing of the radioactive materials. This step can be time-consuming and requires specialized knowledge and equipment to handle the radioactive components securely. The entire decommissioning process is not only about ensuring safety, it also aims to maximize the value recovered from the ship. After defueling and decommissioning, the submarine is prepared for recycling. This often involves removing valuable components and systems, such as electronics, batteries, and other materials that can be repurposed or sold. A case study, the USS James K. Polk. Let's look at a specific example, the USS James K. Polk, a Benjamin Franklin-class ballistic missile submarine. This vessel was decommissioned in 1999 after more than 3 decades of service to the U.S. Navy. The decommissioning process began at the Puget Sound Naval Shipyard in Bremerton, Washington, a facility well equipped to handle such tasks. When the USS James K. Polk arrived at the shipyard, it was loaded into a dry dock. A dry dock is a long, man-made canal designed to facilitate maintenance and repairs on large vessels. It can be flooded or drained to provide workers with access to all parts of a ship's hull. For submarines, this process typically involves flooding the dock to allow the vessel to float in easily. Once the submarine is in position, the dry dock gates are sealed, and the water is pumped out, allowing workers to access the ship. This initial step is crucial as it sets the stage for the entire dismantling process. Dismantling the submarine. After the submarine is secured in the dry dock, the next step is to remove all valuable components and any items that may still be useful. This includes everything from electronic systems to plumbing fixtures. Each component is carefully catalogued and removed for further analysis and recycling. As the dismantling begins, the hull of the submarine is typically divided into 3 or 4 large sections. This division makes it easier for workers to access the interior and disassemble various components safely. The submarine rests on a set of rails at the bottom of the dry dock, allowing crews to reach underneath if necessary. The dismantling process is meticulous, with the hull and interior being taken apart piece by piece. Given the massive size and weight of the materials involved, it is vital to support each component with heavy-duty pulleys and chain systems. This safety measure prevents any falling debris from injuring the workers and protects the integrity of the remaining structure. The role of heavy lifting equipment. Heavy lifting cranes play a critical role throughout the dismantling process. Even after the submarine is cut into sections, the individual components can still weigh thousands of pounds. Moving these large pieces requires cranes, which allow operators to lift and transport the sections safely. The crane operators maintain constant communication with the ground crew, ensuring that every move is deliberate and precise. A single mistake could lead to a catastrophic failure, risking the safety of the workers below and damaging valuable components. In addition to cranes, workers use a variety of tools for cutting and dismantling the submarine. These can include saws, torches, and specialized cutting machines designed for heavy metal. Safety is a top priority, and workers are equipped with protective gear to minimize risks during the dismantling process. global shipbreaking practices. While the US Navy employs extensive procedures for decommissioning submarines, a similar method known as shipbreaking is used globally to dismantle ships for scrap. This practice has reduced the demand for iron ore and energy consumption in steel production, leading to a significant increase in shipbreaking activities worldwide. Annually, approximately 500 to 700 commercial ships are sold to scrap yards for recycling. A substantial portion of these vessels is processed in countries like Pakistan, where shipbreaking yards are a crucial part of the economy. One of the largest shipbreaking yards is located in Gidani, about 31 miles west of Karachi. This facility stretches for several miles along the coast and boasts 132 shipbreaking plots. Since the 1980s, Gidani has been a leader in shipbreaking capacity, dismantling nearly 100 ships per year during peak demand periods. Logistics of shipbreaking. The logistics behind managing such a high volume of vessels require careful coordination. Ship owners communicate directly with yard operators to determine the timing for decommissioning each ship. This ensures that the operations run smoothly and efficiently. During the shipbreaking process, workers use specialized tools, including hammers, wrenches, and cutting tools, to dismantle the ships. However, these operations cannot occur around the clock. They are highly influenced by tidal patterns. During low tide, more beach area is exposed, making the shipbreaking process significantly more efficient. As the process begins, workers first strip non-essential equipment and fixtures from the ship's interior. This step is crucial, as it allows the team to assess the materials available for recycling and to identify any hazardous substances that need to be removed safely. Once the non-essential items have been cleared, workers remove hazardous materials, ensuring compliance with environmental regulations. This may involve the careful extraction of asbestos, oils, and other toxic substances. The cutting process. Steel cutting is performed using plasma cutting machines, which employ ionized gas to slice through thick steel. When enough scrap material has been collected, cranes are used to transport it around the yard, ensuring efficient processing. Once the interior elements have been removed, the crew identifies suitable anchor points on the ship's hull to attach chains, securing the ship to anchor points on the beach. This stabilization is crucial for the subsequent dismantling steps. Using winches located on the shore, crews can drag sections of the ship out for cutting. The dismantling typically starts from the top deck and works downward, allowing the team to focus on cutting through weld joints to maximize the recovery of undamaged parts. As sections are detached, they are moved with cranes and further cut into manageable steel sheets. Any excess rust is removed during this process, facilitating recycling efforts. These sheets are then processed into molten steel, which is cast into ingots or billets for transport to the market. Decommissioning oil rigs. In addition to ships and submarines, other maritime structures, such as oil rigs, also undergo decommissioning processes. Oil rigs, located far offshore, are vital for extracting petroleum and natural gas from beneath the seabed. However, like submarines, they eventually reach the end of their operational lives. Once decommissioned, these structures are removed from the water following a predetermined dismantling plan. The top side of the rig is separated, lifted by heavy lift vessels, and transported to shore. The legs of the rig are often cut into sections using explosives or specialized cutting tools. After the structure has been brought ashore, any hydrocarbons or hazardous materials are removed from the sections. The metals and other materials are frequently recycled for use in construction or manufacturing, similar to the process used for dismantling ships. Artificial reefs, a unique solution. Another innovative approach to decommissioned oil rigs involves converting them into artificial reefs. This technique enhances marine biodiversity by providing hard surfaces for coral and other organisms to attach to. The first rig to undergo this transformation was towed to a predetermined site in the Gulf of Mexico and sunk, creating a new habitat for marine life. The structure quickly became colonized by various species, promoting ecological growth and providing shelter for fish. Not only do these artificial reefs enhance biodiversity, but they also support local fisheries by creating new habitats for fish and other marine organisms. By converting decommissioned structures into reefs, we can turn potential environmental hazards into thriving ecosystems. Old ships can also be repurposed as artificial reefs. The Gulf of Mexico, characterized by its sandy and muddy bottom, lacks the hard surfaces necessary for marine life to thrive. By sinking these vessels, we create new environments that foster diverse underwater ecosystems. Environmental and economic impact. The processes of dismantling, recycling, and repurposing large vessels serve critical environmental and economic purposes. They mitigate potential hazards posed by aging or obsolete structures, ensuring that these materials do not pose risks to marine life or the environment. Moreover, the recycling of materials contributes to sustainable practices by reducing the need for new raw materials. This helps conserve natural resources and lowers the environmental impact associated with extraction and production processes. Through initiatives like the creation of artificial reefs, the decommissioning process also plays a role in enhancing marine habitats. These efforts not only benefit the environment but also promote economic opportunities in coastal communities reliant on fishing and tourism. As we've explored today, the decommissioning and recycling of submarines and other maritime structures are complex processes that require careful planning, execution, and adherence to safety standards. By responsibly managing the life cycle of these vessels, we not only protect our environment but also contribute to sustainable practices and economic growth. Thank you for joining us in this exploration of a vital yet often overlooked aspect of naval operations. I hope you found this video informative. Be sure to subscribe to our channel to stay updated on our latest content. Until next time.